So far we have seen some, let's say, theoretical aspects of lists. We have said that they are an abstract data structure and they represent a sequence. But we have even seen how to define them in Python. But does that really relate to something that we will end up using? Is this just I don't know, something that mathematicians use? Well, the thing is that no, this is a very useful type of data structure that we actually use all the time. In this case, I guess that's particularly easy to believe because the name of list is a name that we use. We make our shopping list, for example, or we have our list of orders in websites. So there are many uses for lists. Okay, for example, we can, when we want to gather data from groups of people, for example, or of other entities, we frequently store them in a list. And with Python, you will find yourselves working many frequently with lists. Whenever we want to compute the statistics, we very frequently need to access all data in order, and the natural thing to do that in Python is to use a list. Whenever we are streaming something, we may want to put that data in a data stream, and that naturally appears as a list where data appears in order depending on the time it was produced. Things that you wouldn't think of as lists, as for example your internet browser history, is itself a list of pages. So lists are used to store data so it can be accessed conveniently. And what does that mean? Because I have this strong bond between the pieces of data and their position in the sequence, I don't need to traverse to access all the data in order. I can jump directly to the element I'm interested in as long as I know its position in the sequence. And that is something that we will be using a lot, and something that makes lists the best option when your data has this sequence order. Okay, in general, to access the ith position, the position number I in this case, in my sequence, I will use this syntax: the list of my the name of my list variable, square brackets, and the index. In this case, the I index. Okay. Two small issues here. First, remember we said that lists are indexed from number 0. So the first element in the list is element number 0, and the 7th element in the list is element in position 6. Okay, we will see some more details about this in a second. One has to be especially careful not to list a position that does not exist. If you do that, you produce an out of bounds error. Okay, and your code will not run. If I have 10 elements in my list and I try to access list name of 20, then I will get an error. Notice that if I have 10 elements in my list and I try to access list name of 10, I will also get an error because we have been saying list name of 10 is the 11th element on the list. Let's see that in the code. Okay, so we define once more another list as this list that contains many things, and we even pictured it here bigger. The first thing that we will do is that we will paint their indexes. My list is called 0. This, as I was saying, is position 0, position 1. The 1, 2, 3, 4th element is in position 3, and the 12th element is in position 11. Python also allows for a very cool thing, in my opinion, which is negative indexes. So in the same way that we start indexing here, we can also start indexing here. Okay, so if I want to access the last element in my list, I call that -1. Of course, -0 doesn't exist. So if I do that from the other side, from the end of the list, then I start indexing at -1. Second from last is -2, third from last is -3. Okay. So with this syntax that I mentioned before, I can access as many elements in my list as I want. And I can do that, and that will be very important in the second part of the course, very fast. So jumping to one element on my list, if I know the position of the element that I want to jump to, is very efficient and very fast. Okay, let's run this code. And as you can see, we have again defined the same list and printed it, and then we have accessed some of these elements. Okay, the first element, the sixth element, in position 5, okay, and so on and so forth. The last element using the length of the list, which we know to be 12, so we access element 11, not the length of the list, and the element in position -1. Okay, third from the back, you can, as we were saying, run the code here. Let's also show you the error that I was mentioning before. If I ask for an element that's not on the list, so as I was saying, the list contains 12 elements, so it goes from position 0 to position 11. So let's ask for position 25, 26, okay, and I get this index out of range. The same happens if I ask for position 12, but if I ask for one of the positions in the list, position 10, then I get something. Okay, so here we have indexing in lists, positive indexes, negative indexes, and the fact that when we use these indexing properties, we are accessing elements very efficiently and very fast.